Hello, welcome to Chapter 3, Homework Questions 99 through 104. Question 99. One way to solve absolute value equations is to think about looking inside the absolute value. The inside must be positive or negative, so you should solve the equation both ways. For example, you could record your steps as shown at the right. Solve each of the equations below to find all possible answers and check your solutions. Start with A. We have the absolute value of 9 plus 3x is equal to 39. So as the direction stated, we're thinking inside the absolute value could either be a positive or a negative 39. So we're just going to set up two different equations. 9 plus 3x could equal negative 39, or 9 plus 3x could equal positive 39. And we can just solve both of these equations. So x equals negative 16, subtract 9, divide by 3, and x is equal to 10. So x equals negative 16 and 10, and those would represent our two solutions. It also does say to check your solutions, and you can do that as well by plugging them back in to see that they are true. I'll just show you the first one, but I won't do the rest. So the absolute value of 9 plus 3 times negative 16 should equal 39, and that's 9 minus 48. And that's the absolute value of negative 39. And the absolute value of negative 39 is 39. So that checks. And then you can also plug in 10. 9 plus 3 times 10. And that's 30 plus 9. So that's 39. The absolute value of 39 is 39. So once again, it does check. Alright, on part B, we have the absolute value of 2x plus 1 is equal to 10. Whoops. Make that look like a bar. And so we know that 2x plus 1 could equal negative 10, or 2x plus 1 could equal a positive 10. We'll solve both equations. Subtract 1, divide by 2, so negative 5.5. Subtract 1, divide by 2, and that's positive 4.5. So we have, once again, two solutions, negative 5.5 and 4.1, or 4.5, sorry. Alright, C, the absolute value of negative 3x plus 9 is equal to 10. So we know negative 3x plus 9 could equal negative 10, or negative 3x plus 9 could equal a positive 10. Subtract 9. That's negative 19, divide by negative 3, and I'm just going to leave this one in fraction form because the decimal I'll get a repeating number, so 19 over 3. And then on my other equation, when I subtract 9, I get 1, divide by 3, or divide by negative 3. And once again, I'll leave that as a fraction, negative 1/3. So we have x equals negative 1/3, and then 19 over 3. And so you'll see me putting those in numerical order when I am writing them down here. And the last one, D, we have the absolute value of 3.2 times x minus 4 is equal to negative 5.7. So 3.2x minus 4 could equal, oh wait, hold on, it is equal to a negative 5.7. So we need to recognize that, or be able to check our answers, because the absolute value cannot equal a negative number, so therefore this one is a no solution. We don't have to set up the two cases. Now if we happen to set up the two cases and solve, you're going to get two answers, possible answers, but when you go to check them, they will not be true. So that one is a no solution. Question 100. Find each of the following products by drawing and labeling a generic rectangle, or by using the distributive property. So on A, I'm going to use the distributive property. 5x times x is 5x squared, and 5x times 6 is 30x. Those are not like terms, so we can't combine them. On part B, I'll show you the generic rectangle. We have negative 9y and times 6 minus 3y. So negative 9y times 6 is negative 54y. Negative 9 times negative 3 is a positive 27. Y times y is y squared. So B is negative 54y plus 27y squared. And then eventually we'll start rewriting these so that the first term has the highest exponent, 27y squared minus 54y. Question 101, for each generic rectangle below, find the dimensions, then write the area as a product of the dimensions and as a sum. So 2x squared and 10x. We can have a 2x on that side. 2x times x gives us x squared, and then 2x times 5 is 10x. So that means 2x squared plus 10x is equal to 2x times the length x plus 5. On part B, what's going to give us 2x squared? We can put a 2x times an x, and then 2x times 5 is 10x, just like we did a second ago, and then x times 3 is 3x, and then 3 times 5 is 15, so we have 2x squared. We'll add our like terms of 10x and 3x, so that's plus 13x plus 15 is equal to the dimensions x plus 5 times 2x plus 3. Question 102, solve each of the following equations. Be sure to show your work carefully and check your answers. So on the first one, we'll use the distributive property. 2 times 3x is 6x. 2 times 4 is 8. We can add 8 to both sides. 6x equals 30. Divide both sides by 6, and x is equal to 5. I'll check the first one by plugging x back in. 3 times 5 minus 4 equals 22. So 2, that's 15 minus 4. 15 minus 4 is 11. 22 is equal to 22, so it does check. Alright, on B, we have 6 times 2x minus 5. I'm just going to go ahead and distribute. So 6 times 2x is 12x. 6 times 5 is 30, so it's minus 30. And then this negative gets distributed inside as well, so it's negative x minus 4. So I'm going to add x to both sides, that's 13x. Then add 30 to both sides. 13x equals 26. Divide by 13, x is equal to 2. And I'm not going to check the rest of them, but plug 2 back into the original equation to check it. Part C, 2 minus y plus 2. So once again, we're going to distribute that negative 1 or that negative. So it's minus y minus 2 is equal to 3y. I'm going to add the y to both sides. Combine my like terms. 2 minus 2 is 0. Divide by 4. And y is equal to 0. And then the last D, we're going to distribute the 4. So this is 3 plus 4x plus 4 equals 159. 4x plus 7. Subtract 7. That's 152. And x is equal to 38. Question 103, multiply each of the following expressions. Show your work. So we're going to use the generic rectangles on these. We have x plus 3, 4x plus 5. So we're going to find all the areas of the 4 rectangles and then combine our like terms. So therefore 4x squared plus 17x plus 15 is what happens when you take those two lengths and multiply them together. Part B, same thing. Set it up, negative 2x squared minus 4x times 3x plus 4. So negative 2 times 3 is negative 6. X squared times x would be x to the third power. Then you have negative 4x times 3x would be negative 12x squared. 4 times negative 2x squared is negative 8x squared, and then negative 4x times 4 is negative 16x. if we combine our like terms, we're going to get negative 6x cubed, and then right here, we can add those, combine those together. That'll be negative 20x squared minus 16x. So on part B, if you multiply those two together, you will get negative 6x cubed minus 20x squared minus 16x. Alright, on part C, we have 3y minus 8 and negative x plus y. So 3 times negative 1 is negative 3, and then xy. Negative 8 times a negative x would be positive 8x. 3y times y, 3y squared, and negative 8 times y is negative 8y. Let's see what we have. We have 3y squared minus 8y minus 3xy plus 8x. So no like terms on this one. And you might have them in a different order, which is perfectly fine, but you should have positive 3y squared minus 8y minus 3xy and plus 8x somewhere in your problem. Alright, in D, we have a little bit bigger of a rectangle here because we have more things that we have to add up. We have a 3x, a 5y, and a negative 2, and then a y and a negative 4. So we have 6 boxes we have to figure out. So 3xy, 5y squared minus 2y in the last box, and then we have negative 12x minus 20y plus 8. So any like terms, it looks like we have common y terms, and it looks like that's it. So we have 3xy minus 12x plus 5y squared minus 22y plus 8. Question 104, solve each of the following equations for the indicated variable. We need to show all our steps. Part A, we're solving for x. We have y equals 2x minus 5. So we can add 5 to both sides. Y plus 5 is equal to negative 5 plus 5 is 0. So it's equal to 2x. Now we can divide by 2. And so x is equal to y over 2 plus 5 over 2. You might have just divided everything by 2, and that could have been y plus 5 divided by 2. So either one of these would work. Part B, solving for w. So we have p equals negative 3w plus 9. So we'll subtract 9 to create another 0. P minus 9 is equal to negative 3w. And divide by negative 3. Once again, you can do it individually or you can divide the whole thing. W is equal to p minus 9 divided by negative 3. If you divide each term by negative 3, then it would be negative 1/3 p plus 3. Once again, either one of those would be correct. C, solving for m. So we have 2m minus 6 equals 4n plus 4. So we can add 6 to both sides. 2m equals 4n plus 10 divide by 2. And m is equal to 2n plus 5. And last, D, solving for y, we have 3x minus y is equal to negative 2y, so we can add the y to both sides. 3x is equal to negative y, and then we can just divide by negative 1. And so y is equal to a negative 3x.